There we go. Okay, we're going to look at a few revision strategies today, and I want to introduce you to some bits, review a few bits that you've done over the last few sort of weeks, and basically reassure you all that you're all doing amazing. So that's the plan. If you've got any questions or if there's anything you want me to go back over, drop it in the Q&A box, because we've got Miss Martinez here, happy to pass on any questions or answer any that she wants to. Okay, as you can see from the board, I've got the whole idea of revising, and I know as teachers we're always like revise, 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 but we don't actually tell you too much about how. So I want to do a little bit on how to sort of get started with that. And I do think this message in the middle is important about keeping calm, as well as the one over here which says just do it. I mean, it helps to actually do some revision. Okay, so with that in mind, the point of it, and if you've been in my class before, you will have seen this before, essentially is to make sure we're going over information we've already learned. Okay, when you learn something, you make new connections, but if you don't use it, it disappears. So the reason we revise stuff is so that we can actually remember it. And if you go over stuff frequently, it forms a link in your brain, and sometimes it'll be stuck there forever, but that's not necessarily a bad thing. So that's why we do it. Where we do it, ideally somewhere where it's quiet, so you haven't got any distractions. If you're revising any subject, not just science, you need to be able to focus. So not watching TV, not being on WhatsApp or whatever latest trend app is, but actually being focused. And the what, setting realistic goals. I actually think this one at the bottom is a bit too big. Revise evolution and complete one past paper. That's quite a lot to do in one session. I would set little mini 15-20 minute goals, but make them realistic. So don't say, I'm going to revise all of Physics 1 that we've done since we started it, because that would be cray-cray. Okay, so how do we revise? My key thing, do not avoid the ones that make you go, yeah. Okay, there are all topics, and it's the same for us teachers, that make us feel uncomfortable, we find them difficult. Don't avoid them, because they'll just get worse. Okay, so do something you like, and then try the really tricky bit, and then do something else that you like. Now, the when on here used to say when you get home from school, so you're not awake. Obviously, at the minute, we're not going in much, but so I've put when you're awake. It is pointless trying to revise when you are so sleepy you can barely keep your eyes open. You're not going to be able to actually focus. So when you feel nice and alert and focused is when you should be revising. This I really think is important in terms of revision and life and everything, okay? If you need help, don't be afraid to ask. No one's going to judge you for it. Share your worries. This could be to do with work, it could be to do with anything, but share them, otherwise you bottle them up, you get stressed. So just share. If it's revision stuff, you could ask somebody else, or you can ask a teacher. I myself am happy when someone in my class asks for help, and hopefully they'd agree that I respond pretty quickly, they get the feedback they need and they get help. And I'd imagine, or I'd hope, the rest of the department are the same. So ask for help if you need it. We're never going to judge, and we always want to help. Right then, where am I at? Revision ideas, okay? So it's all very well good, us teachers telling you to revise, but you need some ideas on what to actually do. So I always tell my classes to record themselves talking into their phone and play it back. And they'll always look at me a bit like, what are you going on about? That's weird. But that whole idea of repeating it and hearing yourself repeat it can actually help. It's not for everyone, but it's an idea. BBC Bite Size, YouTube, all these videos. Oh, hello. Notice how I clicked on, I accidentally caught my mouse. Sorry about that. BBC Bite Size, YouTube, lots of stuff out there. Seneca, I've introduced, I think most of you have come across that. GCSE Pod, loads of different ways, whatever works for you. You could make a quiz. So you could do card matching games. You could just do a typical, you know, question and multiple choice style quiz like the polls we do. Past paper questions. We've been giving you a lot of those. That helps with exam techniques, but do keep trying them. Mind maps and posters, always fun, and you get to use colours. Flashcards, they're great. just make sure you actually use them. You don't make the most amazing flashcards and then shove them in a corner and forget them and then remake them. That's a pointless exercise. So make them, use them, and make them tatty by the end of it. Highlighters, I love highlighters. Colour coordinate. Do topics link up? Can you colour coordinate that? They're really useful. Post-it notes. I like making walls of post-it notes. So write down keywords on post-it notes, move them around a wall or a door, whatever takes your fancy, but they're quite useful. You could make PowerPoints, especially as we're doing a lot of stuff online at the moment. You can work in groups, so you could do your work, then share it with someone and they can check it. And I've been doing some group work with people in my classes on Zoom, and that helps because we get to talk things through. So you could try that. You could try teaching your family and your little brothers, sisters, anyone around. You could try testing them as well. And my favourite idea is writing songs, as well as actually use YouTube to find songs. There are a lot of songs about science. Some of them are really cheesy, but some of them are really good and they get the point across. And some of them are cheesy, but they're really good. Okay, so that's always something to try. Hopefully that's given you some ideas on what to actually do. My key summary is have a positive attitude. Don't think, oh, I can't do it. Think, I can do this. You might want to prepare a revision timetable. I'm more looking forward to the future for that. So not right now, but revision timetables help. Be honest with yourself and do relax. Don't do revision, pointless. And as like I said here, work for about 25 minutes and then take a 5-minute break and use a variety of tools. Yeah, so don't use the same thing because that'll get really boring. Try different things, try mixing it up. Okay, this is Physics P1 topic contents. Okay, we've got energy stores, systems and conservation of energy, which hopefully most of you actually did in school. We have energy resources, which was the whole renewable, non-renewable, wind, solar, biomass, geothermal, hydroelectric, all that sort of stuff that you did. We have current electricity, which was current, series, V equals IR, all those sort of bits that Mr. Collins did. Then we've got mains electricity, which was what I did last week, which was the plug, alternating direct current, trying to think, bits of the plug, the national grid, and then a few other equations. Try to remember it all off the top of my head. You can see I need to go away and revise it. You'll notice in red at the bottom are particle models of matter and atomic structure, radioactivity and nuclear reactions. These two bottom bits you have not done, but I thought it would be nice to show you what is in P1 and actually reassure you that you have covered a lot of the content of Physics 1 and you will, you know, over time as well get to cover the rest of it. So there's no panic about that. And when we're talking revision at the minute, we're talking these top 4, okay? But not to try and do it all because you've only got a week, that would be cray-cray. Okay, this is the tick list, and if you've been in my class, you will have seen it before. If you've raised your hand, I'm afraid it doesn't do anything, so do put a question in the box if you have one. Okay, just in case. That's why you're putting your hands up. This is the P1 tick list, and hopefully you've seen something similar before, and I'm going to ask your teachers to share it into your classroom for you. You can see I've just copied the first bit, which says describe a system as a group of objects, describe changes in energy stores, calculate kinetic energy, calculate elastic potential energy, calculate gravitational potential energy. These are some of the bits. With the tick list, my suggestion to help you as a starting point is to red, amber, green it. So if you do not know what a system is of a group, that a system is a group of objects, highlight it red. If you did know that, highlight it green. If you think you can calculate kinetic energy, for example, is another one, but you don't know how to rearrange it, that would make it amber. Okay, hopefully that's making a bit of sense, but color code it and then share it back to your teachers because they will know what you're feeling confident with then and what you need help with, and they will be able to provide support with that. If anyone's got any questions, do pop them in the Q&A box. I'll take a brief pause for a second just to check if there are any about this.
Hi, Miss.
Hello.
Hello. Just a couple of questions they were asking about the test. I tell them that you will let them know.
Okay, so we're going to do it as a quiz, and it's going to be a one quiz for all, which means it's not going to be difficult. It's not going to be, I don't think, a past paper or anything. It's not going to have any reference on setting or anything like that. It's literally being done as a quiz so that you can see what you've learned over the time of the webinars and things. It may not even have energy in it. It may just be focused on electricity because that's what the webinars have been about.
Thank you very much, Miss.
Hopefully
And
that-
quick question.
Yep.
Will the equations that they need to know, will we just give them the list of the equations?
I am getting on to that bit, so if you can give me probably to the next slide, I will explain the equations bits for you.
Thank you very much. All
Okay.
now.
Right, so as I said before, tick list, red, amber, green, share it back to your teachers so they can help. In terms of the equations, thank you for asking about that. This is part of a equation sheet that we have in the department that, again, I'm going to get shared with you. And this is, we've got two versions. This is the version with all the answers on. And the other version has gaps on terms and units, and I'm going to share both. And excuse me if I have to shout at Cat in a minute. My cat is being a bit of a pain. So we have equations. Right. Excuse me. Right, say hello, now down. Sorry about that. We have the equations on the left. So for example, this one here, which is kinetic energy equals 1/2 m times v squared. Two sheets will be provided for you. One will have the equations listed here like this, just with the letters and blanks on this side. And the other one will have what you can see here. I think there's about 15 to 20 that you'll need to learn. I am not suggesting you try and learn them all in one go because that would be insane. But the more that you can learn, the better it will be for you. Especially equations like V equals IR, that one comes up all the time. What I would suggest is with revision strategies with these, get some flashcards, write the equation like this on one side, and then on the other side, write the terms and the units. And then you can test yourself if you can remember what EP equals M times G times H is, for example. Has anyone got any questions about the equations? And again, apologies about the cat.
Hi, Miss.
Hello.
Nice cat.
Thank you.
I have a question about that. We will go over this again in September.
I'm hoping so, but I'm imagining we will. We definitely will be going over it before you get to your GCSEs. So do not panic. One thing that will be taken into account is the tick lists. So if you've got big gaps, we will know that and we can support with that and we can help with that. Do not worry if you're stuck on stuff and you need help with stuff. We have plans in action and we are super and we will help you. Not that we're super, but we want to help and we want to get things sorted.
That's for sure. And one more. Can you give an example for an equation flashcard again, please?
So for example, if I was going to make a flashcard, I'll use the middle one. I would write on the front of it, EP equals M times G times H. And that's it. That's all I'd write on the front. Then I'd flip it over. And on the back, I'd put EP equals gravitational potential energy and the J for joules. I'd put M equals mass and then the unit. And then when I'm testing myself, I'd pick up all the equation cards and I'd look at it and go, okay, what does P stand for? P stands for power. Oh, what's the unit for power? Oh, I can't remember. Okay, I'm going to have to look on the back, flip it over, and then I could see that. So it just gives you a way of checking if you can remember what the letters mean and the units as a sort of first step. Okay, hopefully that helped.
Yeah, thank you, Miss. And they're asking about when is the quiz?
I believe it's going to be winging its way to you tomorrow. Not literal winging, you know, but it should be in your Google Classrooms tomorrow. I believe it's going to be ready tonight, but we don't want to upload anything, or I don't like putting anything on after 3 o'clock.
Thank you.
No problem. Okay, gonna wiggle it on. I've put this slide in because your teachers will share this PowerPoint with you. It's just there if you want to have a look at it. So this is all the units that you will need to know. And as I said, there's quite a few, and you'll notice that the numbers are a bit dodgy because I actually deleted some out. Okay, so you'll need to know weight measured in newtons, force is measured in newtons, mass is in kilograms, and so on. Because, again, a revision idea, you could see what ones you know, and then I've actually put the answers on this slide for you, okay? I'm aware some of them you won't have come across, and you'll notice that speed, velocity, momentum, acceleration are on this slide and not the other one. They're ones that come up in P2, so you don't need to worry about them. Again, I've just put it in as a sort of thing to help you learn, because you'll notice in physics 1 and in science you can get marks just for putting the unit. Okay, so that's something I've chucked in for you to have a look at. I think at this point I decided I'd probably have been nattering too much and that you'd need a poll. So I can stop chatting at you, I'm going to launch a poll. Okay, so nice is hopefully simple. I just told you the answer. What unit is the unit for mass? Is it Newton meter, kilogram, or Newton? And I should just check in that you're all aware that this is the higher webinar, not the foundation webinar. Okay, got about half of you answered. So what's the unit for mass? If you're a little bit twitchy with this one, I'll give the clue that there's mass and weight and they're both different things. They're linked, but they are different. And if you've heard cheesy songs, and we mentioned them earlier, there's mass versus weight. Do, do, do. I can't remember anymore. Well, I can, but I know my singing's dreadful, so I'm not going to sing anymore. Okay, I'm going to give it 2 more seconds, then I'm going to click end. Okay, so I'm just going to share the result with you. 60% of you were spot on. Kilograms is the unit for mass. Newtons is the unit for weight. Weight is the effect of gravity on mass. So the pull of gravity on mass results in a force, which is why it's newtons. Okay, and I believe I've got another poll. Yep, so unit for energy. Okay, this is the next one. I've only done 4 polls today, I'm afraid, lovelies. Okay, so what is the unit for energy? Is it joules, moles, ohms, or amps? And some of them you will have been hearing a lot of recently. One of them you won't have heard since chemistry. Going back a bit. I'm now singing the mass versus weight song in my head, in case you're wondering why I'm bopping. Okay, I'm going to give it a little bit longer, just for the last few of you to actually answer. Dooba-dooba-dooba-dooba-dooba-dooba-doo. I'm sorry if my dooba-doobings are distracting. Okay, I'm going to end that poll and share that with you because you're all amazing. 87% of you know that joules is for energy. And just as a little tip there, that is anything energy-wise. So kinetic energy, gravitational potential energy, thermal energy, energy, anything with energy in it, it's going to be joules. Another little tip for you is they'll go, if you've got 50 joules of gravitational potential energy, assuming no energy is lost from the system or something weirdly worded like that, how much energy will there be at the bottom of the hill? And the answer, if you've got 50 at the top, would be 50 at the bottom. Okay, unless they're telling you it's lost some through heat being transferred to the surroundings, what you start with, you end up with. Okay, it's a little tip. I've seen many a question where they've done that and it really confuses people. Okay. Equations, again, I've just put this in for you as a little thing if you wanted to test yourselves. So what equation links weight, mass, gravitational field strength? what equation links kinetic energy, mass and velocity? And again, I've put this in because your questions will often give you two of the numbers and then what they want you to calculate. So if you can recognize the equation and put them in the right order when they're written like this, you'd be able to do so when you actually practice them. And again, just because I wanted to be nice, I've put the answers on the next slide. Okay, so again, you could make flashcards. You could put, you know, on one flashcard, what equation links mass, weight, gravitational field strength, and then on the back, you could write the equation out. So weight equals mass times gravitational field strength. Anyone making notes, gravitational field strength is normally 9.8. It should be given to you in the exam, but sometimes they don't. So I'm just throwing that number out. Gravitational field strength on Earth, I should add, is 9.8. Okay. I wanted to show you some examples. Oh, Miss, you've demuted. Is there a question?
Yeah, good question. It's just about the quiz again. What day is it gonna be due in?
I would imagine next Tuesday, because we normally put things on for a week.
Thank you.
I would imagine we might keep it over and over in Richmond because I know you've got some time to catch up there. Okay.
Okay.
Okay, I wanted to show you some exam questions. I'm not expecting you to do this, I just wanted to talk it through. So the diagram shows a builder using a plank to help load rubble into a skip. The builder uses a force of 220 newtons to push the wheelbarrow up the plank. Use the information from the diagram to calculate the work done to push it up the skip. Okay, it's only a 2 marker. The first thing you've got to realise is you're being asked to calculate work done. Okay, and if you can remember, I'm hoping you can, work done equals force times distance. Now in the question, and if you're in my class, I would be getting you to highlight. I don't know if I can, I'm going to try. Oh, let's see, will it work? Nope. Thought I'd try it. I've got a funny pointer now though, so woohoo. So work done equals force, which is 220, times a distance. Now the distance is up the plank, which is 2.6 meters. So for this question, it would be 220 times 2.6. And then because they probably want a unit, or I would put one in anyway, 220 times by 2.6 equals, and then the answer and the unit work done is an energy, so the unit would be joules. Hopefully that works for you. I haven't actually calculated it myself, so I'm very quickly going to do that. Yes, I know I'm using my phone. I should have a calculator present, but I don't know where I put it. So 220 times by 2.6, 572 joules for anyone who actually had a go at that. Okay, I'll put this one in. Again, I'm not going to get you to do these. I have got 2 questions in here that I want you to try, but they're not sort of exam-y ones, so don't worry. A student finds some information about energy-saving light bulbs. A 30 watt, there's a clue, maybe. Light bulb uses 600 joules of electrical energy in a certain period of time, and in that time it produces 450 joules of light energy. The rest of the energy is wasted. Calculate the wasted energy. Okay, now for that, you've got a total of 600 joules going in, 450 going out as light, and the rest is waste. So it's nice and simple, 600, and hopefully you're all saying this one in your head, 600 minus 450, and yes, I know I could do this in my head, but actually sometimes it's best to check on a calculator that your head answers are right, and you're allowed to in science. So you should, if you've had a go at that, worked out that the wasted energy is 140 joules. Then it says what happens to the energy wasted by the light bulb. My key go-to answer with anything to do with energy waste is it's lost to the surroundings, or it dissipates to the surroundings, or it dissipates the surroundings as heat energy, anything along those ideas of heat and going to the surroundings. And then it says calculate the efficiency. And hopefully you can remember the equation for efficiency. So it should be efficiency equals useful over total. So if I go back to my numbers, my useful energy is the 450 of light. My wasted energy is 600. So if I then plug that in, 450 divided by 600 gives me 0.75. If there was a little percentage symbol just over here, what I would then do is times it by 100, which would tell me my light bulb is 75% efficient. Does anyone have any questions about that question? Too many questions in the sentence.
Hi, Miss.
Hello.
Just a quick point. You say 600 is the waste energy, but
No,
I know you mean the total.
150 was the waste. The total in was 600 joules, because that's what went into the actual light bulb.
Excellent.
And then that's split into the 450 joules of light with the 150 that was the rest of it that's wasted. So you'll notice it totals up to the 600 that went in.
Excellent. I got a couple of questions about that, Miss. What was the answer for number 1?
150 joules.
You already answered that.
600 minus 450 gives you 150.
Excellent. And one more, yeah, already you answered that. Should we leave it as percentage or decimal number?
It will depend on the question and the number of marks available. So this one's only a 2 marker. So 0.75 would probably get you the marks. Actually, it would. But sometimes they might ask for you to put it into a percentage, in which case times it by 100, which would get it to the 75%. So look at the marks available. If you're unsure, you wouldn't lose marks for going into the percentage bit, which you times it by your answer by 100 to do that.
Together. Thank you. And again, I think, what was the answer for number 2?
Number 2 is the energy is wasted to the surroundings as heat. So it says what happens to it. It's lost as heat to the surroundings. That would be my go-to, because energy in any situation, or any situation it comes up with where it said asking about wastage, it's lost to the surroundings, and it's always as heat. If you remember friction, so if you've got objects moving up a hill, if I always do this in class, rub your hands together, they start feeling hot. That's energy being lost as heat because of friction. So that's why I always say heat is your go-to answer, and to the surroundings.
Thank you very much. That's it for now.
Okay, awesome. I do have this. I've chucked this in again. Circuit symbols. There's always 1 or 2 marks available at minimum just for drawing a circuit symbol. I haven't put these on because I actually want you to go away and try and find them and learn them. But you'll need to know a filament bulb, battery, voltmeter, ammeter, resistor, thermistor, diode, variable resistor, fuse, LED, and LDR. You'll also need to know the difference between a cell and a battery. Now, a cell is one, I'm trying to do it in hand form, of the little batteries. So if you think that's a cell, and then a battery would be more than one of those lined up. There is a really funny video. If you type Kung Fu circuit symbols into YouTube, there's a hilarious video where they're like, cell, battery, and they do hand gestures. I find it hilarious, but it does also help me learn them, like resistor. Sorry. And they do say it in that tone as well, if you ever watch the video. Just makes me giggle. I've got a little pole, and I picked a mean one. Anyone know what this is? Naha. You might need to move the pole to the side. When I launch it, I do drag them myself, but I don't know if they do. But what is the symbol on the screen in the middle? Is it a battery, a voltmeter, a diode, or a fuse? And it does actually look like some of you have been learning your circuit symbols, so woo woo woo! Sorry, that was really cheesy, but makes me excited. Okay, gonna give it a little bit longer. Some of you haven't answered. Oh, there we go. We've got some of you answering. I'm going to take the lack of answering with I don't actually know what that is. Okay. Going to give you a bit longer.
Hi, Miss. Sorry to interrupt.
Yep.
Quick question about light bulbs. What's the difference between a filament bulb and a normal bulb?
Okay, so I'll finish the poll and I will come back to that.
Thank you.
Yep. Okay, so I'm going to end that and I'm just going to share. Okay, and 81% of you correctly got that was the symbol for the diode. Okay, now the filament bulb and a normal bulb, you've got LED bulbs, light emitting diodes, they're the fancy ones. A filament bulb symbolizes the circle with the X in it. You may also see a circle with a line that goes sort of along and then up and loopy. Essentially, they're bulbs that have got a wire in the middle, and when they heat up or when electricity goes through it, that wire in the middle heats up, and that's where we get light from. It's also why the old filament bulbs tend to break, because the wire in the middle breaks. I'm not 100% sure how the new energy efficient light bulbs work. I don't think they have that bit of wire through them, which is why they're more efficient. I mean, if you think about it, the old filament bulb has a bit of wire that has to heat up to light up. That's not going to be efficient because you're getting heating involved and energy being lost as heat. I hope that answered your question. I'm afraid I'm not big on how the fancy new energy efficient ones work. You might have to Google. But I do know filament bulb, it's the wire and it.
The other one. Thank you very much. That's correct. Yeah. Thank you.
Okay. Very quickly, because I'm aware that I've been going for a while. On the board, and this is purely because it came up last week, are some graphs for current potential difference graphs. Okay, and we've got current on the y-axis and we've got voltage on the x-axis. And this graph, if you were going to describe it, is described as directly proportional. So essentially, any graph question where you've got a straight line, so voltage is 2, current would be 2, current's 4, voltage would be 4, just as number examples, that's directly proportional. The filament lamp bulb is not directly proportional, because as one goes up, the other doesn't go up, and it curves across at the top. Okay, and if you were to describe why is this not, I think it came up as, why is this filament lamp one not a ohmic resistor? It's because it's not directly proportional and it has a curve. So this one here is the one that you would see for an ohmic resistor. It just means that as it goes up, there's a constant temperature and voltage and current are proportional to each other. This one over here is the diode, and energy only flows in one direction with the diode. Hence, we only have the line coming up on this side. But again, it's not proportional because voltage here is about 2, but it's not 2 on the current line. That's just me trying to describe graphs a bit so you can at least describe that that's a directly proportional, and it goes through the origin. Bit in the middle is the origin. Sometimes there's a 2 mark, describe this graph, directly proportional through the origin for the second mark. Okay, and I'm sorry this is all random bits and bobs, it's just me trying to pick bits that you need. Okay, this links into mains electricity and one of the big bits that I was going over and over last week. So an electrical circuit is shown in the figure below. The current is direct. What is meant by direct current? And you know what's coming up, don't you? This is my last poll, by the way, which means we're nearly there. Okay, so what is meant by direct current? Is it a current that continuously changes direction? Is it a current that travels directly to the component? Or is it a current that travels in the same direction? Okay. This links back to last week where I kept talking about ACDC. Now I want to go, we're on the highway to hell, which is me now singing ACDC. I'm terribly sorry about that. Okay, I'm going to give it a little bit longer. Again, I can see just by percentage numbers, some of us aren't too sure. Do not worry too much, as I said before, this is stuff that we will be going over again when we can. So we're not going to leave you with big honky claps. Okay, I am going to end the poll in 2 and 1. Okay, and I'm going to just share the result because majority of you got that. It is current that travels in the same direction. So the key thing with ACDC is alternating current, changes direction continuously. And if you remember the graph, it does that, positive to negative, whereas direct current will do that, straight long, same direction. It's a bit meaning that it said directly to the component, but then it wouldn't travel past the component in that idea, which is why the correct answer is in the same direction. Now, I am aware of the time. I did have another question on here. This is just, I'm just going to talk it through. This one is a common question. So the equation that links current, potential difference and resistance, and you hopefully have noticed I kept going on about V equals IR. That is the correct equation for this. The V is the potential difference, the I is the current, and the R is the resistance. So V equals IR, and you would actually get a mark if you just wrote V equals IR. I would recommend actually writing out potential difference equals current times resistance to make sure you're all good. What I would also say is it doesn't matter what way round you order it. So you could put resistance equals potential difference divided by current, as long as you've got it correct. I just, for some reason, always remember V equals IR. And then we've got calculate the potential difference across the battery in the diagram below. Okay, so you're being asked to calculate potential difference across the battery. Several things on this question. It's a bit trickier. It's 3 marks, which means you'd need to do 3 things. I'm aware of time, so I'm going to go quickly. The first thing is resistance adds up in a series circuit. So you'd have to add the 20 and the 10 together to make 30. Okay, so you'd write 30 for resistance. Then our current is 0.4, and because V equals IR, V equals 30, which is 1 mark, times by 0.4. That gets you 2 marks because you've got the equation in the right order and you've added up the resistance. The 3rd mark would obviously be for doing your calculation. So 30 times by 0.4. And again, notice how I'm just loading my calculator. 30 times by 0.4 equals 12. So you'd then put 12 volts in there, and that would get you your 3rd mark. Hopefully that was nice and clear for you. I'm not actually going to click on to the next slide because I'm aware I've been going for 40 minutes and you've probably had enough. There is another little bit, one little bit of the question here, which is just this one. So current, potential difference, power, and then the power. And just so you're aware, the answers are on the last slide for you, should you want to have a go at them in your classroom. I've got 5 minutes, so if you've got any questions, ask them now. Otherwise, you're obviously free to go, and thank you for being very focused and coping with me dribbling on. I'm also just going to stop recording, otherwise I'll keep dribbling on.